These are the notes for solving rational equations. We have already simplified rational expressions. So we have added and subtracted rational expressions. We've multiplied and divided them, but we weren't actually looking for a solution. We were just simplifying them. So now we're actually going to be looking for a solution to each one of these. So if you'll look, you already know how to solve these simple rational expressions that are here. So you can go ahead and do that, because you already know how to do that. And I'm sure it immediately jumped to your mind that you should cross multiply. And so you get 5x equals 27. Divide by 5 and you get x equals 27/5. I'm sure you all remember how to do that. And then for b, we would get 4x equals 42. Divide by 4. Simplify this so you get x equals 21/2, or 21/2. And then for c, it's a touch different just because it's got a group down here. Remember, a fraction bar is a grouping symbol, so that isn't just x and 8, it's x plus 8, like they're married together. So when you cross multiply, I would go ahead and take that extra step and do 15 times x plus 8 equals 30 times x minus 2, so that I don't mess anything up. I remember to distribute. So I get 15x plus 120 after distributing the 15 equals 30x minus 60. And now it's just a simple equation to solve for x. So I'm going to subtract 15x from both sides and add 60. So I get 180 equals 15x, divide by 15, and I get x equals 12. So that's something you're all familiar with doing. As a matter of fact, we love it. It's something we got good at back in middle school. So what method is that we're using? Well, of course, it's cross multiplication. So the next question is, why does this work? Well, the reason that it works is because when you use cross multiplication, what you are actually doing is multiplying both sides by the LCD. And we've already worked on finding an LCD. Now, if you're dealing with a problem like number 1 down here, of course you can just cross multiply and find the answer like you're used to. But for the purposes of this activity and these notes, we are not going to simply cross multiply, and that's because cross multiplication only works across an equal sign. If you'll look down at number 2, cross multiplication will no longer work because of this plus over here. So I'm going to take you through solving a rational equation and explain to you why cross multiplication works, and we're going to solve that. But as easy as cross multiplication is, solving rational equations is just as simple. Now, there is one thing we have to consider when we're talking about rational equations or rational expressions of any kind, and that's the denominator. Remember, the denominator cannot be 0. So we have to take care of making sure we know what our restrictions are. What would cause this fraction to go to 0? Well, in this case, it would be a -3. X cannot be -3, not for this problem, because if it is, that's going to make this fraction divide by 0, and that's not a possibility. Same thing for this fraction. A 4 would cause that one to divide by 0, and that can't happen. So that is also one of my restrictions. X can't be -3 or 4. All right, so now what we're going to do is go ahead and identify what our LCD is, and we're going to put it in this box. I'm just going to go fraction by fraction, look at what's in the denominator, and place it in the box. Now, this fraction has x plus 3. It doesn't have an x, it doesn't have a 3, it has x plus 3, all grouped by the fraction bar. That has to be part of my LCD, so I'm going to put that in the box, x plus 3. And I'm going to group it with parentheses since there's no fraction bar over here. So x plus 3 is part of my LCD. I cannot get rid of it, I cannot change it, so it has to be part of my LCD just like it is. Then I go to the next fraction, x minus 4. That has to be part of my LCD as well. I can't change it, I can't get rid of it, so it's part of my LCD. So now if I look at my instructions, I've stated my restrictions, and I have found my least common denominator. So now I'm going to clear the fractions by multiplying every term by the LCD. Now if you don't remember, let me take just a moment to talk about clearing the fraction. Back in, 8th grade, maybe you learned how to clear fractions, or at least I hope you learned how to clear fractions. You would have a problem like x over 4 plus 3 over 6 equals 2x over 3. And because we don't like to deal with fractions, we can do what's called clearing the fraction. In order to clear all of these fractions at one time, I can multiply the entire equation by 12. So I would multiply this first fraction by 12, my middle fraction by 12, and my final fraction by 12 as well. If I do that, it simplifies this and makes it quite simple problem to do. Because 4 goes into 12 3 times, and I'm left with 3x. 6 goes into 12 twice, so you're left with 2 times 3, which is 6. And 3 goes into 12 4 times, so 2x times 4 is 8x. And then it becomes just a simple one-line equation that I can solve easily, and I don't have to deal with the fractions. So that's what clearing the fraction means. You just figure out what your LCD is. So between 4, 6, and 3, my LCD would be 12. And you multiply the whole equation by that, and it simplifies your equation. It means you don't have to deal with fractions in your problem. Well, we're going to do the same thing with these rational expressions. I've already come up with my LCD, my x plus 3x minus 4. Now I'm just going to multiply every term by that LCD. So my first term has to be multiplied by x plus 3, x minus 4. And my second term has to be multiplied by x plus 3, x minus 4. Well, on my first term, my x plus 3's cancel and leave me 4 times x minus 4. In my second term, on the other side of the equal sign, my x minus 4's cancel out and leave me 7 times x plus 3. Now I'm just going to distribute. I get 4x minus 16 equals 7x plus 21. And now I've got a simple equation to solve. I'm going to subtract 4x from both sides, and I'm going to subtract 21. And now I just divide by 3, and I get x equals negative 37 thirds. Now the last thing I have to do is I have to check this. I solved, now I have to check. Check and make sure your answer is not one of your restrictions. And it's not. So that is, in fact, my answer. So let's do another one. I first have to identify what x cannot be. What would cause these denominators to go to 0? Well, in this case, the only thing that would cause this to go to 0 is 0. X cannot be 0. This fraction isn't affected because it has no x on bottom. Nothing I do is going to change that from being a 3. So the only restriction I have is x can't be 0. Now we're going to find our LCD, going fraction by fraction. My first denominator has an x in it, so I'm going to put that in the box. I can't change it, I can't get rid of it, so it has to go in the box. My second fraction has a 3 in it. That has to go in my box, because I can't change it, can't get rid of it. My final fraction has an x, but I've already put an x in the box. You do not have to do it again. So my LCD is 3x. I am now going to go through and multiply my entire equation, each term, by 3x. So I'm going to multiply my first term times 3x, and my middle term times 3x, and my final term times 3x. When I do that, on my first term, the x's cancel and leave me 3 times 1. On my second term, the 3's cancel and leave me 13 times x. Now my last term, my x's cancel and leave me 7 times 3. You simplify that, that's 3 plus 13x equals 21. Now I'm just going to solve this equation. I get 13x equals 18. Divide both sides by 13. And you get x equals 18 thirteenths. Now, you need to check that against your restriction. X can't be 0, but x can be 18 thirteenths. So that is my answer. And I am finished. Okay, so let's do another example. Of course, these examples are getting progressively more difficult. So let's look at this one. I first have to decide my restrictions. What can x not be? Well, in this case, x cannot be 3, because 3 minus 3 would be 0 over here. And that's the only restriction I have this time. So now we're going to go for our LCD. I'm going fraction by fraction and putting each piece of the denominator in my LCD box. Now my first fraction has x minus 3. It's grouped by the fraction bar. They're married together, the x minus 3. There's no way for me to change that x minus 3 or get rid of it. So it has to go in the box as x minus 3. My second fraction has a 3 in it. No, you cannot just put an x minus in front of it. It's a 3. There's no way to change it. There's no way to alter it. So 3 has to be part of my LCD. I'm going to put it in front in the box, kind of squished it in there, because I like the way that looks better. I like to distribute from the front. Now my last number, my last term, currently doesn't have a denominator, but it really does, of 1. I could put a 1 in the box, but 3 times 1 is just 3. So I'm going to leave my LCD as 3 times x minus 3. Now I'm going to multiply every term by my LCD. So my first term is going to be multiplied by 3 times x minus 3. My middle term is going to be multiplied by 3 times x minus 3. And my final term. Now over here on the left, the far left, my x minus 3's cancel out. So they are gone and leave me 3 times x. In the center, the 3's cancel out and leave me 1 times x minus 3. In my final term, 1 times 3 is just 3 times x minus 3. Now I'll distribute to simplify this. And now it's just a simple equation to solve. Let's go ahead and combine like terms. On the left side, I've got 3x plus x, so I really have 4x minus 3 equals 3x minus 9. I'm going to subtract 3x from both sides. Add 3. So I get x equals negative 6. You've got to check that against your restriction. Well, x can't be 3, but it can be negative 6, so that is my answer. All right, so let's move along, checking what your restrictions must be. And in this case, x cannot be negative 2. This second term, I'm going to go ahead and put a denominator there because we've got all these fractions to deal with, but it's just a 1 under there. Nothing will alter that and change it, so it doesn't cause a restriction. Let's look at our LCD. My first fraction has an x plus 2 that has to go in the box. My middle term, which I made into a fraction, just has a 1. I could put a 1 right here if it makes you feel better, but 1 times anything is itself, so you don't have to put the 1. My last term, or my fraction over here, has an x plus 2. I've already written that in the box, so you don't have to write it again. So my LCD is x plus 2. Every term in my original problem is going to be multiplied by x plus 2. My first term, my middle term, and my last term will all be multiplied by the LCD. When I do that, my first term, the x plus 2's actually cancel each other out, and I'm left with just x. In the middle term, there is nothing that cancels, so I have the original x times the x plus 2. And in the last term, my x plus 2's cancel out, and I have just 5x plus 8. Let's distribute to simplify this. X times x is x squared. X times 2 is 2x. the left-hand side, I've got x's I can combine. So I have x squared plus 3x equals 5x plus 8. Now, I have x's and x squareds in the same problem. This is quadratic, which means I'm either going to have to use the quadratic formula or factor. Either way, you have to move everything to one side. So I'm going to subtract 5x, and I'm going to subtract 8. So I get x squared minus 2x minus 8 equals 0. This does factors nicely as x minus 4x plus 2. So my solutions are x equals 4 and x equals negative 2. But again, you must check those restrictions. And remember, this restriction said x couldn't be negative 2. So this one's not actually an answer. This is. So your final answer is x equals 4. All right, last example, number 5. Now, in order to know both my restrictions and to find my LCD, I first have to figure out what pieces are involved in my denominators. So this trinomial has to be factored as x plus 3, x plus 2. Now that I've factored it, I can see my restrictions. X cannot be negative 2 or negative 3. We're going to find our LCD just by going fraction by fraction and including every piece. My first fraction has 2 pieces, x plus 3 and x plus 2. I have to include both pieces. I can't get rid of them. They have to be part of my LCD. My second fraction is an x plus 2, but I've already put that in the box. My last fraction has an x plus 3, but I've already put that in the box. So that's it. X plus 3, x plus 2 is my LCD. So I'm going to multiply every term by the entire LCD. X plus 3, x plus 2. X plus 3, x plus 2. And x plus 3, x plus 2. Now once I do that, I see that on the far left fraction, x plus 3's cancel, and so do x plus 2, and all that is left is that 3. In the middle, my x plus 2's cancel, and I'm left with the x plus 3 and x minus 1. And in the far right, x plus 3's cancel, and I'm left with 7 times x plus 2. Now, we're going to have to simplify this by foiling this out. X times x is x squared. X times negative 1 is negative x. 3 times x is positive 3x, so that's going to leave me positive 2x. 3 times negative 1 is minus 3. And then I'm going to distribute. Now I've got like terms I can combine on the left. 3 and negative 3, actually those cancel each other out. X squared plus 2x equals 7x plus 14. I have another quadratic that we can either factor or use quadratic formula. Either way, you got to move everything to one side. So I'm going to subtract everything from the right and move to the left. X squared minus 5x minus 14 equals 0. That factors again easily. X minus 7, x plus 2. So x equals 7 and x equals negative 2. But again, I have to check against my restrictions, and my restriction said x can't be negative 2. So the final answer is x equals 7. And that is how you solve rational equations.